gravitational pull. But there are some supercharged turbo models that could actually break free and rocket out into the universe. These are called hypervelocity stars.
Hypervelocity stars are normal stars like the Sun, except that they're moving out of the galaxy at well over 1 million miles an hour. And that's beyond the escape velocity of the Milky Way.
The need for speed begins with a normal pair of co-orbiting stars that get too close to the edge of a black hole. Just as the disabled Apollo 13 command module got a boost of velocity by maneuvering close to the Moon's orbit, the hypervelocity star gets a huge gravitational kick from the black hole, severing the bond with its binary partner.
The star closest to the black hole is captured into a very tight orbit around the black hole, and so it loses this energy. The other star gains that energy and is ejected with this very large velocity as a result.
The ejection of a hypervelocity star is much like a slingshot effect. At the instant the binary star's orbit is broken, the hypervelocity star is launched with incredible force into the void of space.
They've been voted out of the Milky Way, and they're destined to drift into the infinite depths of intergalactic space. It's very unlikely that these stars will ever affect the Earth.
Fortunately, the eventual death of these speedy stars will occur far away from our solar system. It's the death stars on our own block we need to keep an eye on. In cosmic time, their fuses are lit, and we have a front row seat to their annihilation. In remote corners of the universe, countless stars are biding their time on death row, sentenced to spectacular, violent endings. Closer to home, there are a few dozen stars within 20 light years of the Earth, and a few of these are preparing for death.
I think we're safe from the dangers of a normal supernova. In the case of a gamma ray burst, we're not so sure.
One is in the stellar system Eta Carina, a supermassive star about 100 times bigger and 1 million times more luminous than the Sun. In 1843, a buildup of pressure ignited a gigantic eruption of light seen from Earth. But the star survived and formed a dust cloud called a nebula. At a distance of just 8,000 light years, we'll have a front row seat to its annihilation.
We think it's going to turn into a black hole sometime between now and the next 1 million years. And as it collapses, it has enough matter that it can produce a powerful gamma ray burst.
Unlike the star, Wolf-Rayet 104, Eta Carina doesn't have us in its crosshairs.
We know that the rotation of Eta Carina is not pointed towards Earth. So lucky for us, the pulse of the gamma ray is not going to be directly impacting Earth.
When it happens, the explosion will likely be the brightest supernova ever witnessed by mankind. Unless the title goes to another Death Star contender that's even closer to Earth, Betelgeuse. Located in the Orion constellation, about 500 light years away, Betelgeuse is quickly burning through the last of its nuclear fuel.
Betelgeuse is a very massive star, about 20 times the mass of the Sun, and it's within 500,000 years of exploding.
People have been noticing that Betelgeuse has been changing a lot over the last decades. It's actually shrunk considerably, about 15%. What that means, no one is sure, but everyone's keeping an eye on it.
Some scientists believe Betelgeuse could unleash a gamma ray burst. People on Earth have little to fear if it does. Like Eta Carina, the star's axis points safely away from Earth. Not only that, But Betelgeuse may also have a built-in blast shield.
Its explosion will be relatively normal. It won't be a gamma ray burst because there's this thick hydrogen envelope in Betelgeuse, and that hydrogen envelope will probably prevent the jet of particles and radiation from emerging. There's too much material through which the jet of radiation would have to pass.
Betelgeuse will shine intensely for a brief moment, but it won't compare to the final moments of our nearest star, the Sun.
Average stars like our Sun have nice long lifespans, fortunately for us, and our Sun is about halfway through its 10 billion year lifetime, so it's about 4.5 billion years old. That makes it middle-aged.
Scientists estimate that the Sun will live another 5 billion years. But our problems could begin much sooner.
Our own Sun is very gradually getting brighter, getting more powerful. And within a 500 million, certainly 1 billion years, the Earth will become so hot that the oceans will have evaporated away. So we don't quite have 4 or 5 billion years to worry about this problem. We have to worry about it on timescales of hundreds of millions of years.
Billions of years after the Sun renders the Earth devoid of life, it will enter a final phase known as a red giant. It can't explode and produce a supernova because it's not massive enough. But most scientists agree on the final chapter. As a red giant, its density will decrease, and the Sun will balloon outward, devouring its nearest neighbors.
At this stage, the red giant stage, the Sun will probably expand and engulf Mercury, Venus, and maybe even Earth itself. So that would pretty much be the end of Earth.
Of all the dangerous Death Stars in the universe, the one most likely to destroy the Earth is our own Sun. While it marks our planet's ultimate end, it's merely a part of the cycle of creation. Death Stars take life, but they are also the origin of life.
The heavy elements in our bodies, quite literally, were generated by previous generations of stars and ejected into the cosmos by stellar explosions. So we would not be here if it were not for the fact that some stars explode violently at the end of their lives. As Carl Sagan used to say, we are made of star stuff. We are made of star dust.
As the explosions continue, the resulting heavy elements may one day reseed the very foundations of life, far from the Milky Way, on a new blue planet, in a new corner of the universe.